So then we looked into key value, key value based key value pair based parameters, and we have to have an order, right? If you are trying to have all three kinds of parameters, then the formal parameter should be the first one. The variable argument parameter should be the second one, and key value based parameter should be third one, something like that. Okay, and then we have to look into other method called as zip. This zip method is very useful in many places. So we have seen enumerate. If you take a list and then trying to look at the indexes and values both, then you should be using enumerate method. Enumerate method will give you indexes and values like this, right? And then zip method will actually try to combine multiple lists like this. So there is one list, another list, and another list. The 3 employee data, right? If you want to get all the employees into one tuple, all the salaries into another tuple, and then all the joining dates into another tuple, we should use zip method. Zip method will combine the index, the corresponding index values into one value. See that? If I don't have in the second one, if I don't have one value, see that it is actually combining only the indexes which have got equal number of values. Got it? Do you recognize what's happening there? Names all came into one tuple, salaries all came into one tuple. Actually, the name, salary, and the joining date, 3 are in one list. But when we use zip method, it actually got combined like this. Got it? Did you understand?
Yeah.
This is very useful. When we do the machine learning will identify the importance of features, and we know the column names, and we know the importance of each column name. That there is there is a data set where you need to find out the house price, and the house price will be found out by using that SFT area, number of bedrooms, number of bathrooms, and the distance to school, amenities, all the amenities. Right? These all will have different weights. Weights in the sense they'll have different levels of importance. Generally, SFT area has the most important thing, and then number of bedrooms will have most important thing, and number of floors and the amenities will have most important thing. Right? We know that from business, but there may be some parameters which are even more important than what we know. So the algorithm will find out that importance. That importance will be found out by a numeric number. The coefficient of the column is going to be the number. I actually showed you that theta 0 plus theta 1 x1 plus and so on, theta and xn. Those thetas are the important. Higher the number, more the important. So you will get numbers separately and you will have features separately. You need to zip them together to know which feature has got how much importance. So application, I am trying to explain the zip methods application, and we will see that in the course we will see that clearly. Okay, did you understand the example I took, or is it a bit confusing?
Yeah, it's good.
Okay, so we will we will know it even more when we enter the course. Okay, so zip, it will actually give you a zip object, but if you want to convert it to a list of tuples, right, you need to actually typecast it. This is typecasting, we call it. Right? We are converting the zip object into a list object, and you can traverse through.
So that means Rama, zip always returns that tuple, right?
Zip returns the zip object. See this here? The type of that zip object is a zip, right? The type is zip. Got it? And we need to convert that zip into list of tuples and then traverse. Or you can traverse through zip object also.
Okay.
See this here? I zipped 3 lists and then iterating through that, right?
Yeah, but it looks like tuple, right? Brackets.
No, when it got combined, it became a tuple. See, that's what I asked. Did you understood? See this, the original one is a list, right?
Yes.
When we combined, what happened? All these three, Ajay, Vikram, and Karthik, these three became one tuple,
Yeah.
right? For 1500, 1000, and 2000 became one tuple.
Combination tuple. Okay.
Dates became, so corresponding index items are becoming tuple. That's the zipping.
Yeah. Got it. Yeah.
Right? In our application, right? In our AI, we'll have like features, like X1, maybe feature one, maybe SFT area. I'll put it like this: SFT, and then number of floors. Right, like that you will have features and then importances. Right, importances will be some scores, maybe 10, maybe 5, 2, maybe 5, like that. Then will be zipping it, for Z in zip of and then print Z. Maybe some spelling mistakes, right? So what now we know SFT area is this much important, number of bedrooms has got in real time, right? You'll have 1000 features. Then it will be very useful to know which feature has got how much importance. Got it?
Yeah. Got it. Thanks.
Yeah, we will see that example anyway. Right? But knowing that the method is there is a good thing, and you have that all the Python pre-built methods, a list of pre-built methods, right? So you can look at that and then understand more methods are there. So I just try to show the type conversion. Even without type conversion, also you can traverse through it. Okay. Any other questions?
No, Rama, I'm clear.
Okay, good. And then we have this dictionary, right? And there is a method called a sorted. Let me take it, list and try to. So I'll take some fruit names. Right? But I have taken this sorted is a pre-built method in our Python. Sorted is a pre-built method. So now sorted of and then I will put apple in the last. And see that when we did that sorting, it actually gave me an order, right? Original list is going to be, right? I think I should put name. This is a keyword, right? So it is actually showing in green. I should not be taking keywords as variable names. And the sorted list is actually showing in sorted order. But if you have a dictionary and you want to use sort, and the sorting I wanted to do on the values rather than indexes. If this is a dictionary, right? You guys know this. So let me try to show you. So I am doing tab here, right? When the variable is already present in the memory, if you type 3 letters and say tab, it will come. See that it is a dictionary, right? Key value. Now I want my intention is that I wanted to sort the dictionary on the values. When I sort the dictionary on values, right, I should get orange first, then apple next, and then mango third one. Do you agree? I want to sort the dictionary on values, not the keys. Do you agree?
Yes.
Right? So the sorted method is there. I'm trying to use that sorted method, and I passed the dictionary. See this? It came it gave me the other mango, sorry, apple, mango, and orange. It is taking the keys, okay, and then sorting it in ascending order by keys, not the values. Okay. So if you want to do that sorting on the values, you should use a you should actually tell the sort method that the sort method need to work on the values rather than keys. To do that, we need to use a lambda function, or I'll try to a lambda function. We have to use a lambda function. Let me try to show you one simple example first, and then we'll go into values, how to use values thing. Right? Sorted. This is a bit confusing, so that's where I'm actually tumbling a little bit to explain you how to explain. Okay? So in sorted method, right, there is a parameter called as key. This function takes the object which need to be sorted. It can be a list, it can be a dictionary, it can be a set or whatever. Right? And then there is a parameter called as key, which actually takes the and which key it should be sorting. So here in the dictionary, the key is apple, orange, and mango. The values are 95, 2, and 202. But here in the sorted method, the key can be anything. The key is equal to whatever value you pass. The sorted method will take that as the key. Okay, it is the sorted method's key purpose is to sort the data. There is no relationship between the dictionary's key and the key inside the sorted method. You got the distinction, right? There is no relationship between the key parameter in the sorted method and the key inside the dictionary. There is no relationship. Whatever value you pass into key, it will take it. How to pass a value? Let us see. So let me try to do one thing first, and then we'll see. I am trying to explain lambda function. Fun. I'll say so. I'll just print it here. I'm not going to do anything. Just print. Expect 101.2. I think we need to find. What? Okay. Let me try this out. What happened here? It's fun too. Maybe fun is a keyword.
No.
No, it's not a keyword, right? So it should work.
We no need to pass argument for fun in the lambda, I think so.
No, we need to actually. We need to pass. Okay. It is not returning. Maybe that's the problem.
Yeah, I'm thinking so.
Yeah.
No, already your lambda x is the argument, right? Again, you are passing x to the function
No,
too.
no. The x is the value from the object. Here the x is going to be a tuple. That's what I wanted to show. The x is a tuple, and in from that x we are actually taking the index 1 as the value. Index 0 is the key, right? In the dictionary, apple is index 0, orange is index 0, mango is index 0 because it is a tuple. Okay? And the value is going to be index 1, index 1, index 1. I wanted to print that tuple here. So I don't know why it's not working. Why is it saying 2 arguments? Is that yeah, see that key I forgot. See this? See that, when I actually pass x, right, it is taking the key only. See that? That only, it's a confusing term, right? In sorted there is a key parameter. In dictionary we have keys. It is taking key as the value. When I say x, okay. So you take the tuple, right? I was actually expecting a tuple here, not the key value. Sorted and x, and it should actually
No, return you missed in the function too, I think so. The print
return
is
is
that
okay. Return is okay. Okay. Return. What the heck? Okay, let me input from here. Okay. Return I definitely missed, but my expectation was different and it's not acting as I expect. Okay. So okay, that's where it is throwing error. But
yes.
when I printed in this, right, inside this, it should actually print the value of both, PRA. What is the PRA?
First index of each
First index
apple, I
of
believe.
Yes.
X. I think it should take the tuple. I don't know why it's not taking tuple. That's okay. So here, right, when we say key is equal to lambda and x, what is the x? X is going to be tuple from this dictionary. I wanted to print that dictionary, that tuple there. And fun one is going to take the, let me print here. Still it is showing that one. Try to print the type of it.
I think we need to pass it x of one index to the function one. Here lambda in the lambda.
Yeah, actually,
you're passing the first one only, key only you're passing. You need to pass the value, right, in the function.
No, actually, when you do lambda function, right? I don't know key is taking it like that or not, but when you do a lambda function, it actually takes the whole object into the
Lambda.
right. So it is. See, now here I said x, right? and I said x0, the order is on the key, apple,
Yeah.
mango, and orange. When I say
That's what.
x1, give me 1 second. When
Yeah,
I
yeah.
say x1, the order changed, right? Mango, apple, and orange, right? Mango is what? Mango has got 220. Orange has apple has got 95 and orange has got 2. So it started in descending order. Okay, but without having x2 values, how are we getting 0 and 1? That's the question, right? I was actually trying to print those two values there in the function. Got it? Got my intention there? But somehow it's not working. It's actually acting weird. My expectation is that x should print two values, and out of which we are taking one value. See here. I think I'm doing something wrong there, but now we figure that out.
I think here,
Fruit caps.
based on the index value, or
Yeah, in the function
it
you are
is sorting
passing.
actually.
The function I'm passing wrong thing.
Yeah, here you need to pass the x of 1. X of 1.
No, x
No,
of
that
1
also
if I
gives the
pass.
same result, right?
Did you get my point? I think what I'm trying to do here is, if I lambda x I said here, right? And then I'm saying x of 0 and x of 1. That means two values are there, right? Do you agree? X has got two values, two indexes,
Yes.
0 index and first index, right?
Yes.
So I
I
wanted to
think
see both of them in that function.
Okay.
Got it? Got
Yeah.
it? So I wanted to call fun1 and then pass this x which has got two values, and I wanted to show you those two values here. Print x should actually print a tuple. Two values it should print, x of 0 and x of 1, but it is printing x of 1 only, x of 0 only. This error is like it is not returning anything. That's where it is throwing error, because sorted method needs something, right? So it should actually print both values. I wanted to show that, but it's not happening. Something wrong with this. Maybe the way we are calling or the way it is structured. I don't know. Right? But the point here is, when you want to sort a dictionary on the key, on the value, you need to say like this. Why? Because each of the element, each of the item in the dictionary has got two values. It is a tuple. We have seen that yesterday. Right? Even here. Right? Fruit cals has got items. Each item is a tuple. The 0th index is apple and first index is number. So we are specifying the sorted method to take the values, to sort the data. And if you want to reverse it, right, I should say reverse. See, it is sorting in ascending order. Default is descending order. Got it? I don't know why this print thing is not printing properly. So I'll show. I'll actually see this. I'll look into this and show you. I think I did everything right. That's the problem. We think we did everything right. That's okay. This is a small thing. We'll see. Yeah.
I have a question, Rama. Here, can you try with the x of 2 here?
No, x of 2 will throw error.
Oh,
X of
X of 2.
colon, something like that.
No, the x here, x of 2, that's okay.
here I think, yeah, please try.
No, x of 2 will throw error. Huh? Oh.
No, actually
Oh.
what is happening is something, it is taking apple index value, it is taking and sorting. Mango index value 2, it is taking and sorting. Orange index value 2, it is taking and sorting.
Yeah, that's a good point. That's a good point. Yeah. I think I was wrong. My understanding is wrong. Yeah, if we have to sort this I saw this only, right? Let's try to look at it. Oh, we have to do a bigger stuff here, right? We need to take the items and then, okay. So this is how we need to do. I think the list comprehension we have to use. Right? So if we take this fruit cals, right? And then items will give you tuple. Then we need to pass that each item and then take the item. This is, I think, whatever happened is good. Whatever happened is good. Now I'll explain this. See that? Now it is sorted. Whatever happened is good. So my understanding was wrong. Whatever you found out is the right thing. X is actually taking the key value only, that not the value of it. If we have to sort it on sort a dictionary, we need to use the sorted method. Right? That function is still here. Okay. And then the items is actually the tuple. My idea was correct, but the way I understood sorted method was wrong. Okay, so I have taken the tuples. What the items will give? The tuples like this, right? So first tuple I got, and then I specified that key lambda first tuple is the item here. If I say function 2 here now, it will actually give me. Okay, let me explain this first. So the item is taken, and then we are passing the item 1, which is the value. Okay, and then it is sorting. Once after sorted, right, we are actually taking the key value both. For key value, right, we are taking the key and value both and then creating a new dictionary. How am I saying it is a dictionary? Key colon value is a key value pair, and then we are having a curly braces there. Inside curly braces, we have key value pairs. It is going to be a dictionary. Right? Got it?
Yes.
Right. This is correct. I think my understanding was wrong. Sorry for that. And then let me try to do this. Now if I print, this will work now. So here if I say, so lambda functions, and then I wanted to show this sorted method both at once. That's the thing I wanted to do. Yeah. See that? Right here, when I try to print this X, we are getting this dictionary now. This is what I was expecting, and I never actually looked into it. I think so. This is good. Right now you understand how the sorted method is working on a dictionary. Even I understood now, right? So,
Yeah.
Yeah, I understand.
yeah. So now, right, the lambda function, how is it working? Also, you understood. The major thing we need to understand here is lambda function. Sorted method we may not use much, but lambda function, it is a function call inside a function. This is a function, and we are actually doing a function call here. We can write expressions also here. If something and something is happening, you can put if else conditions also here. Okay, so inline function we call lambda function. This is like a function which is taking this parameter function inside brackets, that item, and then next to the colon, what are the statements which are present in that function, kind of a thing. Okay, got it, right? Any questions on lambda function? Okay. So I think I should remove some of the stuff here and then upload. Okay, I'll do that later. So this is how you need to sort a dictionary. The idea was correct, but the way I understood sorted method was wrong. That's okay. Okay. So shall we move on to the next topic, the object-oriented programming in Python. In this total course, right, we will use object orientation in here, and one more place where we'll use pipelines. Okay. So even if you don't understand this object orientation stuff, that's okay, but try to spend some time and understand it. Okay. So in object-oriented programming, there are object-oriented programming is common for all languages. Whether it is Java, any language it is common. So in object-oriented programming, there will be class and an object. A class means it's kind of a design. Okay, you are trying to build a house. There will be design for the house. That is like class. Using that design, you can create n number of houses. Same design, you can create n number of houses. Generally, government builds those kinds of houses, right? So the class is kind of that design, which will be present in a file, in a physical file on the hard disk. When you instantiate it, right, it gets created in the memory, RAM. Okay. So why do you need the object-oriented programming? When we are working on some project, right, we actually have to simulate the real-time scenarios in software. So I actually took a car example. Suppose that we are trying to build an AI system or a self-driving car that actually tries to see whether there is an object when it is trying to park the vehicle, right? Whether there is an object or not, it is trying to find it. So if you want to create that kind of a software, I created a car, and then there are 4 wheels, right? That's a property. Car will have wheels, the steering, accelerator, the gear, and everything. Those are all properties there. And then we are actually initializing the length and width of the car and video stream. Okay. Suppose that the car has got a camera fixed to it, and there is an AI system which actually identifies the objects. Okay. When you reverse, the camera switches on, and then it actually tries to see whether there is an object and how far that object is from the vehicle, and is that an obstacle or not. Okay. So this process video will have all that logic. I didn't write all that logic here. Okay. The stream video is equal to 1. That means, video stream is equal to 1 means return true. There is a obstacle, right? And if it is 0, that means there is no obstacle. It can actually accelerate. So process video, I actually wrote some simple code, right? Generally, we will have lots of code here to identify whether the object is there as an obstacle or not. But I just put some code here. Okay. So self.process video, object found. If object found, right, then please stop and move backward. Right? It will not move forward. And if object is not there, it will move forward. Something like that. Okay. And in this particular example, right, we need to change this manually. And then try to execute it. Okay. So in real time, if you really implement on the video, it will actually dynamically work, whether the object is there or not. Video processing. Process video stream is a function that actually looks into video and decides whether there is an object present in the way of the car or not. But here I hard-coded the value here. Okay, I hard-coded the value. So you need to understand. This is kind of pseudo code. Okay. So parking area will also be calculated here and describe car. What is the kind of car it is? So this is one class which is actually trying to describe the behavior and the attributes. Right? Attribute is wheels, and the behavior is whether it should be accelerating, how much parking area it needs, and then what is the type of the car, and those are behavior things. So we are actually trying to simulate the real world scenarios of a car in a software. Okay, in future when we see the self-driving cars, right, they'll have these kinds of software components present in the car. Okay, so I tried to simulate that. So now with this is all definition, right? This is all called as class, and it will be present in a Python file. I created that. Now I am creating cars. So with these specifications, you can create n number of cars. Okay, n number of car objects. Okay. So now I created car1 where I passed a 0, right? Video stream 0. That means there is no object. There is no object as obstacle. Okay. So I am setting it. I am setting it while creating the object itself. So in a class, this underscore init underscore is a constructor. Constructor means when you create the class, right, the car of 0, 12, 5, and this is actually object creation. Car1 object we are creating here. While creating, we are passing 3 values, right? Those 3 values will be passed into this underscore init underscore, and these values will be initialized. So the first method called when you are creating an object is underscore init underscore. This is a default, Python provided method. When we execute this statement, this method gets executed. Object gets created and this method gets executed. Okay. And then there is a keyword called self. This is like this keyword in Java. This keyword refers the object itself. In Python, self keyword refers the object itself. And then we are actually creating new variables here. Self.length is equal to whatever value we got from outside. What is the value we got from outside? When we created the object, we got 0 as a value for video stream, 12 as a value for length, and 5 as a value for width. If I don't pass length and width, right, it will take 10 and 8 as the default values. And then they get assigned to these variables. Why do you need self.length and self.width and self.video is, if I create car1 will have the values passed here, 0, 12, and 5. If I create car2 with different values, like maybe 2, sorry, 1, I think I should pass only 1 or 0 to the first parameter. And then I say 8 and 3, right? The second object, the car2, will have these values assigned here. So only those values which are present, which are actually assigned to self variables, are used inside these methods. Okay, it is like a human being, it is like a laptop, right? We have a laptop. Laptop is a general specification, general definition. A laptop is general definition. Whenever somebody says laptop, right, we will get that idea that there will be a keyboard, there will be a monitor, and then you can type. There will be a mouse pad, and all that. Right? That is general laptop. But my laptop is different from yours. My laptop will have my own RAM, my own monitor, my own processor, and all that. Right? Those are all these properties. My own, right? That particular object's properties there. And when I switch on my computer, my processor starts, right? And then when I switch on my computer, my monitor starts. Then my dimensions are going to be like this. My description, my computer description will be like. So for the particular computer, the properties will be assigned like this. So like that, right? When you create multiple cars, each car will have its own properties, and those properties will be used inside these methods. So we encapsulated everything. That is called as encapsulation. We encapsulated the behavior and the properties into one software component. That is a class and object. That is object oriented. Did you get it? Any questions here? I am actually trying to explain OOPS concepts in 30 minutes. That's a big challenge, but any questions here? Does it make any sense at all? Okay. Yes. Yes, no.
It is a good example. Yeah, we understood.
Yeah.
Okay. Okay. So these self variables and underscore init underscore are very important, right? If I don't use self here, what happens? I'll show you. So I created a class here, and I am creating an object. I am creating a car here. And when I say describe car, it actually called the describe method here. and then it printed this car. This is just a car, and allotted parking space of 60 SFT. By looking at the dimensions, it is calculating the parking space. So here, if I don't use self, right? See that it is throwing length is not defined. See this here? We actually pass a length here, width here, right, into underscore init underscore method. Okay, but to this method, length did not came as input. If I have width as variables here, right, it would not have thrown error, but there is no way that you can pass, maybe you can pass. You can pass it like parking area, you can pass double comma.
Oh, spelling mistake, I think. Spelling mistake. Length.
Okay. Okay. Right, like that you can do. And individually you can pass, but properties are used throughout your class. It is always suggested that you define them as variables here. If you define them as variables here, right, while creating the object itself, you will assign the values and you can use them throughout the, throughout all the methods, right? If you don't want, right, if you don't want only specific values you want to pass, you can define specific parameters in the method like this also. Okay, so self keyword I used because I wanted to use those, this length and then width throughout the class, or I think. Oh my goodness. No need of passing the parameters. See that it expects one positional argument and it is at 3. Right? I am passing 2, but it is saying 3 because there is self also. Previously, now here the self is there, so it is expecting only 1, but we are actually saying 3. So why do we need to pass self into every method? Because we are actually using that self thing here, right? So, what is this happening here? Can only concatenate. Okay. I think we should actually say comma here. Right, like that. Okay. So this is one car object. The second car object is I created one more with I said 1 here. When I pass 1, right, what happens? It is actually going to say when processing object is there, it will say move backward. Okay. So move forward, it said. When I said accelerate, it said move forward because there is no obstacle. Right? We are passing it in real time. We'll process it and find out what is happening there. Okay. In the real time, what is happening at the site, what we'll find out. But here we are passing this value. When I say that, it is saying that object is there and move backward. So this is encapsulation, and then inheritance. So the generally car will have all these properties. Okay, and then you want to create a sports car and a sedan, right? The only thing I am changing about the sports car and sedan is I am overriding this. We call it as overriding this describe method. So sports car is inheriting car. Okay, so in Java we'll say implements. Okay, implements and interface and class have got two different things.
Is it like extends?
Extend and implement, right?
Yeah.
Inheritance, the interface will do implement, and class and abstract class will do extend. Okay, but here in Java, in Python, in brackets we can specify that. Okay, here you can actually do multiple inheritance also. You can say comma, one more class like that. In Java, it is not supported. Okay, and then describe method is getting overwritten. That means what? This is a new class with all these other methods present, but this method will have different property. This method will behave in a different way. What is the difference here? This is a sports car. It is saying this is a sports car, and I defined a sedan, and in that I have specified this is a sedan car. Okay, two classes I did, and now I am creating sports car with whatever properties. When I say describe, right, it is saying this is a sports car. Right? But rest of the methods are behaving the same way as car. Right? In this car, whatever the output we got, the similar output, same output will come. But only the first output is changing because I have overwritten the method and I'm creating an object of that particular that car, and then when you create an object of a particular class, only the methods defined in that class will get invoked. If you overwrite all the methods, right, all the behaviors will change. If you don't update all the methods, the parents behaviors will be taken there. Parent methods behaviors will be taken there. Okay, so sedan, sports car, I defined, and then I am actually doing this, and then sedan dot number of wheels. So here, this is called as a global variable. On a class, it is like static variable in Java. Okay, in a class, I defined a variable not inside the methods. It is outside the methods, outside the functions. Right? So you can access directly like this. Like sedan dot, and even in the subclasses it has got. Okay, I have defined it in car, but even in the subclasses, the sedan car and the sports car and the sedan car also, we have got this number of wheels property. Okay, so generally these variables are called as instance variables. These are called as class variables or static variables. Okay, instance variables are accessible inside the methods. Global variables can be accessed inside methods and outside also. The instance variables cannot be accessed outside the object. You cannot say car.length because it is an instance variable. You need to create an object and then you will be able to manipulate it using methods. Got it?
Yes, Ram.
So this is kind of object orientation, and this method you need to remember, and this self you need to understand, and then practice a little bit. You will get it. If you have questions, right, I'll explain. Okay, that's about the Python, and if you want, right, we can go into statistics a little bit today. If not, maybe tomorrow we can start. So this is the actual data science course, beginning of data science course, I would say. Shall we go ahead and have some class? We have 25 minutes time. Are you guys okay?
Yes.
Yes, no? Okay, good. Good. So let me start the statistics. So we will get into more details of statistics. Initially, this week, we'll cover a little bit of statistics and then we'll learn the tools. I'm going to show you some examples here like this, the graphs, charts and data and all that. So once after knowing the theory, we'll know practically how to do this, how to do these graphs and all that analysis, how to do, we'll practically see. And then we'll go into details, more details of statistics. So there are descriptive statistics and inferential statistics, two kinds of statistics. Descriptive statistics generally describes your data. What is describing? So if I ask you about maybe Gandhi, right? You will say he's a vegetarian and he was a freedom fighter, and he led the freedom fight very well, right? So Gandhi is a person who lived around maybe 60 years or 70 years, right? But when we ask about that particular person, right, we are explaining it in 3 words, 3 sentences, right? Description, right? There is lots of data about a person, but we are taking 3 major things to explain so that a human being can understand. That is descriptive statistics. In data also, there may be billion records, but there will be some properties with which we can understand with which we can get a high level view of the data. That is descriptive statistics. Like human beings, properties and behaviors, even though the person lived for 70 years, it's a huge data, right? You would have done many things from morning to, in 24 hours, you would have done many things, and in 70 years, you would have done, billions of things. But we are taking only 3 sentences to explain. That is describing a person. Similarly, for billions of records also, there will be some properties with which we can understand, with which we can get a high level picture of what is happening with the data. That is descriptive statistics. Okay. Inferential statistics. Sometimes what happens is you will not have access to the total data. In statistics, we call that as population. Okay, total data, right? If you take exit polls data, right, it's going to be exit polls is like the companies are going to do analysis on small chunks of data, right? Not the before elections, they will not go door to door and try to ask people who they are going to vote, right? They'll take some samples here and there, right? In one city, maybe 10 cities, maybe they'll choose some 10 villages, maybe 10 towns, and they collect samples, and then do analysis on those samples and try to assess what is going to happen in the next elections, right? That is inferential statistics. By looking at a small sample of data, not small sample of data, multiple samples of data, and then trying to assess what is going to happen to the population, right? Population means whole data. If you take all mobile users data, that is population. You want to analyze only the mobile users in your locality or maybe Hyderabad, that is a sample. So generally we'll get access to samples. We'll not get access to the population. Okay. So we will analyze, we look into the samples and analyze, and then do inferences about the population. That is inferential statistics. We'll see in detail, inferential statistical concepts. Okay. And descriptive also we'll see in detail. Okay. Any questions on these 2 statements I made?
Is it like the predictions, like with the limited data, we are predicting for the larger data? Is it that related to the inferential statistics?
Inferential statistics is about prediction only. It's a statistician's approach.
Yeah, with the limited data, we are estimating all the things for the larger data.
Yes.
So with the limited
estimating,
we are making them larger statements.
Estimating is the right word actually. We are trying to estimate. Statistics is all about approximation estimation. Okay, there will not be proper exact data available for you, but still you wanted to make an inference about what is happening. In in India, they look at Kundalini, right, or the Jatakam, right? It is same and similar kind of a thing, right? So statistics is like that. Okay, that's where when they predict, right, there is no guarantee, right? It's a prediction, they say, right? So that's we are going to understand the statistician's approaches, because to understand data, these approaches are needed. Before we do data pre-processing and apply machine learning algorithm, we need to understand it. Okay. Any other questions? Okay. So descriptive statistics, there is a concept called a central tendency. We all know this, we have studied this in our childhood. Mean, median, and mode. Right? Mean is the average of all the all the data. Average of all the data means we have 5 numbers, sum all of them divided with 5 is the average. We know that. But what is the what is the importance in data science? What is the use of this mean in data science? What we need to understand. So suppose that there is a class, and in the class students have got marks between 60 and 65. Okay, and then I calculated the average and I got 63. And when the headmaster asked me how are the students are performing, I said that it is around 63. On an average, the students are getting marks around 63. Is that a right measure? Is that actually describing the behavior of the whatever data there? Is it right? The marks range is between 60 and 65. There are 100 people, 100 students, and the marks range is between 60 and 65. I took an average of all the students' marks and then said that on an average 63 marks they are getting. Is that a right measure, right way of explaining things? Is it right?
Yep.
Right. But suppose that in a classroom there were students like 100 students, out of which 90 students have got marks around 10 and 15. Okay, and 10 students have got marks 99. Okay, 10 students have got marks around 99, and 90 students have got marks around 10 to 15. Can I take mean now and say that the on an average students are getting like around 50% marks? Let me try to draw this. Right now
we can take the mean of the 90% people and the mean of the 10% people, and we can say.
Yeah, something like that. That's like we are what you are trying to say is the measure mean is not appropriate there, right? That's the one statement. If I 90 people are getting marks between 10 and 15, in the range of 10 and 15. 10 students have got marks between all 10 students have got 99 marks. And now if I take average, right, this may actually fall around 40 or 50, right? But this average, the 50 is not representing the data. This data, so when I am taking mean or average, my purpose is to represent the data or describe the data, right? But in some cases, the mean is not suitable, right? In this is the kind of example. So when mean is not suitable, right, we may have to go to mode or median. We have 3 different central tendencies because sometimes data, the central tendency measure may not represent the data. Our goal is to represent the data. Why do we want to represent the data? In one of the scenarios where we use the central tendency is there is some data in our data set, right? X1, X2, and so on. And in this X2, right, we've got some data values and some blanks, okay, some nulls. So because having nulls, we cannot remove the records. We somehow need to fill these null set with some values. We'll take non-null values, all these dashes, non-null values, and try to see how the distribution is. When I say distribution, right, you see this here, 90% of the people, students, marks are around 10 and 15. That means these 90 students data distribution is spread, right? If you take a graph, right, it will be between 10 and 15. Okay? The data may be present somewhere here. Okay? These 10 people's data is actually spread around here, right? So I think 99. So 10 people are actually falling here, right? So the data distribution, by looking at data distribution, you need to decide which measure to use. Okay. So in this case, you should not be using mean because to replace the nulls, because the mean is not representing the data. So when you replace these nulls, right, the data should not get corrupted. Mostly data is actually having similar pattern. You can take mean and replace the values because mostly these values will also fall into the same range. If it is not right, you should go with the mode or median. Got it? In data science, what is the use of mean? Got it? Any questions there? We'll see this in, in an example, we'll see this. Okay. If the data is like this, right, then we should go with mode, right? So most of the people's data is spread here, right? 10 to 15 range. So if you take mode, right, it will actually represent the data. Most of the data it will represent. If you take mode, you may get maybe 13 or 14 or something like that. So that is actually representing the data. 99s only 10, right? 90% of the times it is around 10. So mode is actually going to represent this data. So other central tendency measure is there to represent it, and we'll take this and replace the value, null values. If no pattern is there, if you see this data, right, there is no pattern. There is 3, there is 3, there is 10, there is 12, right? There is 20, there is 70. There is big number, there is small number. In this case, right, neither you can take median or mode. There is no pattern at all to the data. You should take median. How do you take median? You sort the data in ascending order, take the middle number. Sort the data in ascending order, take the middle number to represent the data. This is the central tendency. 20, right? If the data is like this, right, I would say 20 is the average mark the students are getting. So most of the times one number is occurring, then we take that number as the median. Or the way our friend said, right? Take a mean of this and take a mean of that and see which one is like maybe the mean of this may represent the data, like that. We can have our own measure also. Mean, mode, median are the predefined or already found out measures, but we can have our own measure also to replace the nulls inside our data. Got it? Why 3 different measures? Depending on data, you need to choose the measure. Because of that, we have 3 measures, central tendency measures. Got it? Any questions? Can I move on?
Yes.
Okay.
One question there, right? Numbers is 3. What is that numbers is 3?
So this one, the mode of these numbers is 3. That's one sentence. Actually,
Oh, 3. How you got it? You are explaining bottom. Okay, got it.
yeah. So this is like most of the times it is repeating. So we take that as the mode. Whichever number is repeating in the data many times, we'll take that as the mode. Okay. And there is a concept, there is one more thing, like probability mass function, we call it as. What is probability mass function is how many times 3 is occurring out of the 6 numbers? 5 times, right? 5 by 6. And how many times 100 is occurring? 1 by 6. Whichever number's probability mass function is high, you take that as the mode. In continuous data, we call that as probability density function, and in discrete data, we call that as probability mass function. Simple ratio, right? How many times the required number, the number we are looking at is repeating with respect to the total number of data. Like that is, this ratio is called as this simple probability is called as probability mass function, right? We represent the probability mass function is going to be an equation which actually derives this whatever. So in general, in many places it is a simple ratio. In some cases it's going to be formula. We'll see those formulas and all. But for simplicity and to understand what is probability mass function, it is just ratio. How many times a number is occurring in terms of when you look at the total data. Got it? This one concept you understand in probability, that is enough for total data science. We'll cover more probability and statistics, but the base is this. If you have this in idea, right? Whatever is explained is all on top of it, and it is a bit tweak to this. Okay? Got it?
Okay.
So, why am I actually trying to tell this is, we will cover lots of math in this course, right? I am going to cover statistics, mathematics, right? And then programming, and then machine learning, deep learning, all that, right? So when you get into math, if you understand these fundamentals, it is going to be easy, right? Very simple things spoken in complex language. That is mathematics, okay? That point you remember. Very simple things. Mathematics is not that difficult. It is just that when it is spoken in a different language, or terminology is increased a lot, then it becomes a little difficult. Okay? I'll try to demystify or try to make it as simple as possible. Okay. And here I try to explain that the data is like this, right? All the spread, right? The data is spread between 54 and I think 65. 65 is the maximum number. 54 and 65, the range is like around 10, right? I can take mean to represent this data. But if you look at this data, right, the 50 is repeating most of the times. So I have taken 50 to represent the data. In this, right, there is no pattern at all. So I have taken the average of middle two numbers. I said that we need to sort the data in ascending order and take the middle number as mode. But if the number of numbers are even, you will have two numbers in the middle, right? When I sorted, there are 4 numbers before, 4 numbers after. I've got 2 numbers in between. I have taken the average of it. That is going to represent the data. It is the median. When there is no pattern, the median is the approach. When there is some pattern like this, you take most occurring number as to represent the data. When there is clear, range is less. When you say spread or range, they are statistical terms. Spread or range, right? Spread is less. The data distribution, so spread is less. We'll see more of the terminology I'm using, but tomorrow we'll see more. Right? So,
what happens if the mode, if the numbers are unique?
Numbers are unique. Like you say 50s are 3 and maybe 30s are 3.
Not like that. Let's say there are no repeated numbers.
No repeated numbers, you will go to median.
Okay, but for that there is no mode, right?
No more. One of these measures you will take. It is actually to represent. It is like describing. When I gave you that example, right? Gandhi. You describe Gandhi. You took 3 sentences. His life is like around 60 years or 70 years, right?
Exactly.
Like that. The total data I am trying to represent it one number. One number.
Okay.
Why do you need that? You are going to work with millions and billions of records. You have to have an understanding of what it is before you actually do something about the data, right? Something with the data, right?
Okay.
So to understand data, either one of these measures will take depending on the distribution of the data. We'll talk about distribution in coming class. Okay. So there is a range. The range is another statistical measure. Maximum minus minimum is the range. We know that, right? That is simple thing. So they name it and they try to put it as a concept there. Maximum minus minimum is the range. Mid range is average of maximum and minimum is the mid range. So these are all numbers that actually try to describe data. That's why we call it as descriptive statistics. So if you ask like how is the data spread? You can say it is spread across 29 numbers. How do you know it is range? Maximum minus minimum. Okay. And there is a concept called as interquartile range. Okay, interquartile range is, we have seen the median, right? What is the median? This is the data, and we did a ascending order. We sorted the data in ascending order. Right? 2 I have taken first, 4 next, 8 next, like that. I sorted it. And now if I take the middle number 13, that is median, right? Do you agree? This 13 is the median, right? We call that as Q2, quartile 2. Okay. and the first half will have a median, right? If you divide this data into two parts, the first half and the second half. First half will have one more median, and second half will also have another median. Right? The first half's median is called as quartile 1. The second half's median is called as quartile 3. Right? And the data between 1.5 of quartile 3 and minus 1.5 of quartile 1 is called as interquartile range. Let me try to take a screenshot and explain. So if you like, let me take these numbers aside, right? 2, 4, 8, 9, 13, 15, 17, 26, 26, 34. Some numbers they are. Okay. Why we are looking at only one numbers? Because we are looking at one column. This is like one column in the data set with less number of numbers. Okay. When we are working with algorithms, right? We'll take bigger data sets. So here, if I ask you to find out the median, you will say there are 4, 5, 6, 7, 8, 9 numbers. So the middle number is the median. This is the median. Okay, the median's other name is quartile 2, Q2. Okay, and this part you can take as one data set, and this part also you can take as another data set. And on this data, there is another median, right? This is even number of numbers. What is the median? Average of these two. Do you agree? Average of those two is the median, right? 12 by 2 is 6. Right? This is called as Q1. Okay. And here, average of 26 plus 17 is how much? 36 and 7 is 43, 42, 21.5. Right? Is that right? Q3. So this is called as quartile 3. Okay. Generally, if you look at any data set, before quartile 1 and after quartile 3, the data may be outliers. Data may be extreme numbers, not outliers, extreme numbers. Right? So you took data, you took census data, and then you try to do interquartile range, and you may find people who are like less age and more age, right? And then you can actually look at those records only and see what is the, how is the behavior, or what is the other properties about those, right? So interquartile range gives you the kind of extreme, extreme values where you can actually focus. Okay, interquartile range. Okay, and outliers, right? So if you 1.5 of 21.5 is how much? 1.5 into 21.5 is 30, and 1.5 of 20 is how much? 30, right? Around 33, right? Right, 33, around 33, right? This number? Yeah, around 33, right? And this side, 1.5 of 1.5 and
9.
1.5. We need to take this side. We need to move this side. So how to do that? I'm actually
4.
We moved that side, right? In this 21, right? We moved that side 33, but we need to move this side. We need to calculate a number which is 1.5 of this one. How to do that? 3. We need to, right? 0.5 is 3, right? So we need to subtract 3. So it's going to be 3. This side 1.5 is going to be 3. So beyond 3 and beyond 33, the values are going to be outliers. That is the general statistical understanding. Okay. 1.5 outliers. Outliers means the values may not be valid. Okay. So generally we try to take the data, find out the interquartile range, and calculate that 1.5 of that 6 and the first quartile and 1.5 of the third quartile and see what are all the values beyond it, and we may actually look into them carefully because they may be outliers. I'm saying they may be outliers because this is all mathematical calculation, right? We don't know business. Why am I saying this is, if you look at the house prices in Hyderabad, throughout the Hyderabad, the prices may be around 40 to 80 lakhs. The apartment house, 2-bedroom apartment house, the price is going to be between 40 to 80 lakhs. But if you take Banjara Hills and Jubilee Hills, right, the prices are going to be in crores, right? Maybe 30 crores, 40 crores, like that. If you look at the data and try to do statistical data analysis, definitely the Banjara Hills, Jubilee Hills data is going to be beyond that, this 1.5 of the third quartile. Do you agree with my statement? Do you agree with my statement?
Yeah.
Right? So statistics will give you a clue, but in reality, the data is valid, right? The houses are there, the prices are there. If we know business, we will decide that the data is valid and we will keep data and try to work with it. Or build a model separately for that data and separately for this data if it is not possible, right? If you are trying to build a model which is not working, which is not predicting well on the rest of the Hyderabad and Jubilee Hills and Banjara Hills together, then you may have to separate the data and build two models. Okay. If you go by only statistics, what you will do? If you only go by statistics, what is statistics is saying? Banjara Hills, Jubilee Hills houses prices, is it saying outliers or not? It's saying outliers, right? And are you getting it? Guys, are you getting it? Yes, no?
Yes, but still we are confusing with terminology. That external outlier.
Confused.
Yeah, still the terminology. But
Yeah, outlier. Yeah, outlier means data entered into the data by mistake. Somebody did something wrong. That's where the data is in the data set. It is not really the data belonging to this data set. Maybe some device got corrupted, or maybe the data entry operator entered some wrong data. That is called as outlier. Sorry, I will explain that first. Now it's clear, right?
Yeah.
Right now, the statistical tool or the interquartile range will explain that the Banjara Hills Jubilee Hills data is not valid. Okay, but if you know business, right, you will know that it is valid and you take that data and do whatever is needed. If you don't know the business, right, if you go by just statistics, you will remove that data. Removing data is a crime in data science, right? The value is present in data. You are trying to extract value from the data, right? So that is interquartile. We'll actually recap tomorrow and then start from the beginning and explain it in a cool way. Okay. So that's it for today. Any questions you can ask.